Hello everyone, reporting today for Fun Robotics Network. I'm Abbas, and with me here today is Team 16917, the Gear Wizards from Minnesota. They have been one of the absolutely most insane teams this DECODE season, just constantly posting newer and newer videos, shattering current teleop records, super fast shooting, everything. Now they're going to be representing Minnesota at the United States Governor's Cup and just have one of the most optimized intakes, shooters, park mechanisms. Just robot as a whole is an absolute beast, and I can't wait to jump into it on this Behind the Bot.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Founded by First alumni, FRCTs understands what teams need. High-quality apparel fast. From t-shirts to jackets and more, with a free 14-day turnaround and faster options available, you can join 200-plus teams who are already saving. Get a free quote by scanning the QR code or going to frcts.com.
Alright guys, so first, before we get started jumping into the details, the first thing I want to understand is just how many iterations you've been through. It seems like your robot changes so much and so rapidly. So what version of this is, what version of your robot is this?
So this is version 2 of the overall robot, switching from aluminum pocketed to solid carbon fiber to increase rigidity, and then each subsystem's been through more than one rebuild, since it's a lot easier to chain.
Got it. Starting with your drivetrain, I would say you guys have a much smaller form factor than teams this season. What was the idea behind that before we jump into the bare motors themselves?
Yeah, we wanted to keep the robot as light as possible, and the best way to do that is to reduce all of the material needed for the frame, and the only way to do that is by making your frame as small as possible.
Got it. And while we're talking about making the robot light, how heavy is your robot right now?
Our robot's about 17.5 pounds, fully loaded.
Got it. And where are you seeing the biggest, improvements in your gameplay as a result of the weight? Like, is it your speed or acceleration? What are you seeing?
We're able to keep a constant speed. Acceleration is not a problem with it because we run a standard RPM, but with such a light robot, we don't have any issues with acceleration, as well as batteries last much longer, so we can run an entire match while not experiencing major battery drops.
I see. All right, yeah, let's jump into the belly of that drivetrain. I think you guys have done some really, really clever packaging. So walk us through what's going on there.
Yeah, so we decided to move all of the drivetrain motors to the back of the robot, and this allows the artifacts to be as close to the ground as possible, which creates a very smooth intaking process. So the motors are shoved all the way back. We cut the shafts and we have low profile encoders. And then from there we have inverse pulley setups. So this GT2 pulley is here and then it's flipped on the other one. And this allows us to run our machined GT2 pulleys that we made in-house. And then from there we use the HTD3 belt to do the last final ratio out to the rev mechanism wheels.
I see. And when discussing those different belting styles, did you start with GT2 on everything or HTD on everything and then you decided to switch, or like why go with the different belt profiles?
We used to use HTD5 last year, and in talking with other teams as well as testing for our own, we realized that GT2 would skip too much on the outer stage to be efficient. So we decided to switch to something with a larger tooth ratio, but still smaller than HTD5.
Interesting. So the high speed, low torque application, you're going with those GT2 belts, and then the lower speed, higher torque application, it's the HTDs. Is that correct?
Yep.
Very interesting. While we're down here, let's talk about hang, I think, since we have a really good shot of everything. Walk us through generally what your hang mechanism is, and then I'll ask more specific questions.
So our park mechanism is a carbon fiber belly pan, and then we use machined aluminum brackets that I made in-house. This is at a 5-degree angle offset so that the robot moves out of the zone as it goes up. And then from there we use, we have a block on the inside of here that is solid aluminum, and then we have the MGN block, and then there's a lock mechanism. And then from there, we just have an axon servo with a spool. It's 1-to-1, and because of how light our robot is, we can do the entire park mechanism without gears.
Wow, so that's just 2 Axon Maxes lifting up the entire robot.
2 Axon Minis.
Two Axon Minis. Wow, yeah, if we could see that, that'd be great. And as far as like speed is concerned, how long does it take you to do this hang?
It takes us about 2 to 3 seconds to do the entire hang or park mechanism from aligning, which is very nice because we don't have to worry about it. We can decide to park at about 2 or 3, like 10 seconds left instead of starting immediately in endgame.
Yeah, that makes sense. And, talking about that aligning, is that something that you've implemented, just autonomous driving to the position, or is that all done manually right now?
So we do it manually because of how much the odometry will drift over teleyap. Even half an inch of air will cause it to be over the line. Aligning it by sight with the corner where your driver station is a lot more accurate. And I can demonstrate the park mechanism going up. So we just start that, and then all we have to do is enable it, and the entire thing will go up.
Wow, that's just incredible. It's, one of a kind, really, seeing how effective it is. And I think there's very few, if any, other robots out there this season that are light enough to implement one-to-one on Axon Minis. All right, yeah, with that, let's jump into your guys' intake. So one thing that I think is very unique with your robot is you have only one motor powering the entire intake-uptake sequence. So walk us through generally what the flow of artifacts is, and then we'll get into the specifics.
Yeah, so zoom in here. So we have a first stage intake, which is on a drop-down. This is passive, and it's sprung down with hard stops. This allows us to open from the gate. And then from there, we enter with the surgical tubing and Andy-Mark more stiff wheels. This helps guide it in, and also the surgical tubing mainly eliminates the dead zone that normal compliant wheels leave with round objects. So the surgical tubing helps kick it in and doesn't leave any dead spots in the robot. And then from there, it goes in and then 90-degree angle up into the launcher. This allows us to have a very short robot because there's not 3 linearly, and then they get stored vertically in here and with one intake.
Got it. You guys have just done so many iterations on this intake. What do you think are the 1 or 2 biggest improvements you've made to it that you would recommend teams around the world really learn from you guys on?
The surgical tubing makes a huge difference for the overall intake performance because of how it's able to deform and reach farther than a normal wheel can. That allows you to run much larger diameter wheels than if you had pure compliant wheels, as well as eliminating dead zones. Those are why they're really efficient for us.
Got it. Yeah, that makes a ton of sense. Talking about the axles, given everything you did on the drivetrain, I can't imagine you're running steel Rex axles on your intake. So what are you running here? What can teams learn from?
So we buy a 7mm hex stock from McMaster car, and from there we use a 2-axis mill and a lathe to add the tap ends and precise lengths. So we don't use a single commercial off-the-shelf part on any of our frame or intake. None of our robot uses any standoff spot. So we just make it to whatever length we need for CAD, and that helps a lot with the form factor of the entire robot, as well as the specific intake widths.
Wow, yeah, that's just crazy. Talking about compression on all of these factors, about how much compression are you running inside the robot, and what does that do for you current draw-wise with your intake?
We run very low compression on the inside of the robot because we only have one motor, the intake. So by doing that, we allow the artifacts to spin in their spot when they're loaded instead of stalling it. That's really important for us, but on the front, we have high compression, which actually isn't just a value, this is sprung down. So the artifact will get caught on this and that'll actually spring it up. And then here is actually a little bit higher compression too, along with the surgical tubing to hit it farther in.
Got it. Awesome. And what is going on with the green Andy-Mark wheel or the green wheel you have inside the robot that's offset to one side? Is that remnant from something else, or how are you using that?
The top one?
No, to the side, in the back.
Oh, that was, we found that artifacts would fall out with one of the designs, so we use that to kind of help them stay in the middle.
Okay.
As they stay in the robot. We can demo the intake too.
Yeah, absolutely. Yeah. We'd love to see that.
So you feed them in.
Wow, yeah, just super, super smooth. Talking now, moving into the turret. I'm sure you guys have a lot of custom things going on there. So starting just with the bearing, what bearing are you using for your turret?
This is a custom bearing stack because of the machining opportunity that we have. from one of our businesses, we are able to run high tolerance bearing stacks, as well as we use a 3D printed gear to drive it.
Okay, and so that's a thrust bearing stack that you've made yourself, or
Yeah,
is
so
it okay?
2 thrust bearings sandwiched with a radial bearing in the middle, and we use standoffs to keep the entire thing organized, and that helps keep all the bearings running nice and smooth.
Okay, and the decision to go with the bearing stack was just weight as opposed to a single large, like 5-inch or 6-inch bearing?
Weight, cost, and then turnaround time were some of the big requirements, as well as height. This is a really low profile turret. So the height was a big factor for us. Being able to control that was really important to reduce the dead zone.
I see. Now, talking about powering this turret, I see you guys have the motor there. Why go for that motor?
So we wanted to keep it simple with only one actuator on this turret. So what we have is a vertical motor, and then it's such a high reduction, we didn't want backlash, so we went with a planetary go build a gearbox. And then from there it's GT2 to here, and then that's just a bearing assembly with a 3D printed gear on top.
I see. Talking about like homing these, with servos, when teams are running servos, you'll have like some absolute position you can go to. How are you homing this turret?
We wanted a full 360 without the risk of it hard stopping and breaking. So what we do is we have a reset mode that we can go into where we can fine tune the angle and then reset. And if it gets turned off during the match and we lose the relative position with the encoder, we have turret presets that will basically, we drive it to a position and lock it for the rest of the match, and we just run manual.
I see. And I see you guys have a Swift servo there too. What is that doing?
That's our gate. So since we have one motor intake, we have to have a way to stop them at a precise point. So we have a gate that just slides out of the way so that they can launch. That's really important to make sure that they don't launch prematurely.
I see. Got it. Now, jumping into your guys' shooter, before we get into software, let's start with hardware. You have just one of the most, I would say, clever shooter packaging assemblies. We've seen a few teams this season run, direct drive shooters, but you guys have done it very, very elegantly. Walk me through what you have going on here.
So, to put it simply, we started with 2 motors on the back belted to the flywheel, but we found there's a lot of wasted space, and then also the bearings that we use there would tend to implode due to the ratings on them weren't great. So we decided to just cut out the middleman and go for a direct drive. And this also really, really heavily improves our efficiency. So we can keep this moving the entire match so we don't have to spin up from 0. And to keep the flywheel small, we decided to go with completely custom. Also because the size that we ran was discontinued from GoBuilda, so we figured why not just make it, because we've been doing polyurethane rollers. So this is a custom molded polyurethane flywheel to a 3D printed core. And then these are billet steel flywheels that we made on a Haas. And then in there we have custom clamps that sandwich the flywheel to the bear motor shafts. And because it's such a low load situation on the shooter, we don't have to worry about bending the bear motor shafts.
Got it. And so you guys are connecting just to that 1/8-inch D shaft on the motor, or what are your spline, or what are you going to on the motor?
So we buy the hex shaft versions of them, and then we use a Dremel to cut them to a position that we want, and then from there we use the clamps to keep it together.
I see. Now, talking a little bit, about iterations with the shooter. I mean, I've seen you guys try maybe 3-4 different shooters. You had counter rollers, adjustable hood. You got rid of them, back and forth. Why settle on this design that seems like it's a fixed hood with grip tape and this custom wheel in the front? Why do that as opposed to the counter rollers or anything else that you had before?
Well, originally we ran with a very similar design, which is static hood with flywheel, but we had one motor, and we had issues with rapid fire, as well as the angle was too shallow, so it took too long to shoot, and also the backspin would cause it to bounce out. So then we moved to a counter roller setup, which had 2 motors here, belts the counter roller assembly with gears, and then we had a 90mm flywheel, which was also a very shallow setup, but it still worked really nicely, so we ran that for our first qualifier. The one problem with it, it shot accurately. Fire zone was a big problem because of how shallow it was. It just shot too high, so they bounce out super easily. as well as it was super inefficient, so we couldn't accurately go to the same spot when rapid firing.
I see. I see. And now, as far as bounce out goes, how have you mitigated that with this shooter?
So we shrunk the entire turret stack down about 10, 15 millimeters from our last competition and launcher. That allows us to make the flywheel smaller and then increase our final height that the artifact exits at. So we're rocking like a 40-degree angle here. And this more so shoots like straight dimes instead of lobs. So we essentially barely adjust the flywheel as we move out. And all it's doing is slamming against the backboard and using the backspin that it creates to basically launch itself down the ramp.
Got it. Now, another very unique or very effective thing that you guys have is shooting on the move. So talk to us a little bit about how you're doing that exactly.
So we didn't want to delve into the super complex physics because none of us are old enough to even take the class at our high school. So what we started with is a velocity based using pedropathing. They have built-in velocity parameters that we can use for our teleop drive. So we use those and we offset those by our current position on the field by a factor of how long the artifact takes to land in the goal from where we're positioned. And then that creates a second pose that follows the robot around. And then it assumes that that's the pose that it's launching from. So it basically sets the robot back in time when it's aiming when we're moving.
Got it. As far as effectiveness that you've seen with this, would you say this is like 100% effective? You don't want to change it at all the rest of the season, or are there improvements you're still looking to make to this?
The shoot on the move stuff is a lot of complex code. So it's going to change from now. But the one thing about it is that it's not amazing for teleop a lot of the time because you're not always moving in the same direction to the goal at the same time. So it's not as consistent because that has to be fully dynamic. We do use it really heavily in auto so that we don't have to stop at the launch position. We immediately leave. And that allows us, because we're moving the exact same path every time, you can predict what your offset's going to be.
I see. And as far as like localization onto the goal goes, I don't see any limelight or any cameras here. So is that entirely pinpoint based?
So the shooter uses the odometer pods on the ball to track its position, and then on the motor encoders,
as well as the pinpoint for odometry calculating.
Awesome. Yeah, that's fantastic. So you guys have some big competitions coming up. This weekend you'll be competing, and then in late February you'll be competing at the Governor's Cup. So I think everyone in FTC is very anxiously and excitedly watching to see just how many records you guys break. So Gear Wizards, thank you guys so much. This has just been an absolutely amazing interview. I know teams are going to be watching this for seasons to come. So reporting for Fun Robotics Network, I'm Abhas, and this is Team 16917, the Gear Wizards. Thank you.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Founded by First alumni, FRCTs understands what teams need. High-quality apparel fast. From t-shirts to jackets and more, with a free 14-day turnaround and faster options available, you can join 200-plus teams who are already saving. Get a free quote by scanning the QR code or going to frcts.com. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.